In the vast expanse of the cosmos, amidst countless stars and galaxies, there exists a small blue planet, a delicate oasis we call Earth. From space, it appears as a fragile sphere of blues and greens, cradled in the black void. Every person you've ever known, every story ever told, has unfolded on this tiny dot. It's both our cradle and our home. Imagine standing on the moon, 384,000 kilometers away, and looking back at Earth. From that distance, our planet seems no larger than a coin held at arm's length. The journey to the moon, if undertaken by car at 100 kilometers per hour, would take over 160 days, a testament to the vastness of space even within our immediate neighborhood. Beyond the moon lies the sun, our life-giving star, situated approximately 150 million kilometers from Earth. Light from the sun takes about 8 minutes and 20 seconds to reach us, traveling at an astounding speed of 300,000 kilometers per second. If one were to journey this distance in a commercial jet, flying at 900 kilometers per hour, it would take about 19 years. Such immense distances highlight the vastness of our solar system. Venturing further, we encounter Mars, our enigmatic red neighbor. At its closest approach, Mars is about 54.6 million kilometers away. But this distance can stretch up to 401 million kilometers when the two planets are on opposite sides of the Sun. Traveling to Mars at the speed of a commercial jet would take upwards of 50 years. These vast expanses pose significant challenges for space exploration, with rovers and probes embarking on journeys fraught with complexities due to constantly changing distances and orbital dynamics. As we journey to the outermost reaches of our solar system, we encounter Neptune, the distant ice giant lying roughly 4.5 billion kilometers from Earth. Sunlight racing across the vacuum of space takes about 4 hours and 15 minutes to reach Neptune. This staggering distance showcases the enormity of our solar system. Launched in 1977, the Voyager 1 space probe represents humanity's insatiable curiosity and desire to explore beyond known boundaries. As of now, Voyager 1 has traveled for over 4 decades, covering a staggering distance of more than 22 billion kilometers from Earth. It's the farthest human-made object from our planet, a silent wanderer in the cosmic sea. In 1990, at the suggestion of the renowned astronomer Carl Sagan, Voyager 1 turned its camera back towards Earth for one final photograph. This resulted in the iconic pale blue dot image, capturing our planet as a tiny, faint speck in the vastness of space. Sagan poetically reflected on this image, emphasizing our responsibility to cherish and preserve our only home. At the very fringes of our solar system lies the Oort cloud, a vast theoretical sphere of icy objects thought to extend up to a staggering 100,000 astronomical units from the Sun, about 1.9 light-years. This immense distance marks the cusp of interstellar space. Scientists define the boundary of interstellar space as the heliopause, where the Sun's solar wind is stopped by the interstellar medium. Beyond this point, the Sun's influence ceases, and the vast realm of interstellar space begins. Beyond our solar system, the closest star system to our Sun is Alpha Centauri, located about 41.3 trillion kilometers away, or approximately 4.4 light-years. Considering our current space travel technology, a journey to Alpha Centauri is almost unfathomable. For instance, the Voyager spacecraft, traveling at about 17 kilometers per second, would take over 70,000 years to reach this neighboring star system. Such immense distances underscore the vastness of space that separates the stars and highlight the challenges of interstellar travel. Our journey now takes us to the grand scale of our home galaxy, the Milky Way, spanning about 100,000 light-years in diameter. This vast spiral galaxy is home to hundreds of billions of stars, each potentially hosting their own planetary systems. Within this immense structure lies a tiny sphere known as the human radio bubble, extending about 100 light-years from Earth. This bubble represents the farthest extent of human influence in the cosmos, the reach of our radio and television broadcasts into space. Beyond this bubble, it's as if humanity never existed. Any civilizations residing in the vast majority of our galaxy would be oblivious to our presence, given that our signals haven't reached them yet. As we leave the Milky Way, we enter the vast, almost incomprehensible realm of intergalactic space, where galaxies float in the cosmic ocean, separated by mind-boggling distances. Our galaxy is part of a small cosmic neighborhood known as the Local Group, a cluster of more than 50 galaxies spread across approximately 10 million light-years. The Local Group is a diverse assembly, including not just spiral galaxies like the Milky Way and Andromeda, but also a multitude of smaller dwarf galaxies. The distances here are so vast that light from one end of the Local Group to the other would take 10 million years to traverse. This scale dwarfs anything within our own galaxy, underscoring the enormity of the universe. Extending our cosmic gaze beyond the Local Group, we encounter the colossal Virgo Super-cluster, an immense collection of galaxy groups and clusters, including our own Local Group. Encompassing a region of space about 110 million light-years in diameter, the Virgo Supercluster is a titanic structure in the universe, containing thousands of galaxies from at least 100 galaxy groups and clusters, each with their own myriad stars and planets. Further still, we arrive at an even more staggering cosmic structure, the Laniakea Supercluster. This immense congregation of galaxies, which includes the Virgo supercluster and extends over 500 million light-years, is our galactic home on a grand scale. Laniakea, meaning immense heaven in Hawaiian, truly lives up to its name, containing the mass of 100 million billion suns. At the heart of Laniakea lies the Great Attractor, a mysterious region of space that exerts a massive gravitational pull on the galaxies within this supercluster. In this vast expanse, our Milky Way, the entire Local Group, and even the Virgo supercluster are just tiny components of this gigantic structure. As we reach the boundaries of our cosmic exploration, we encounter the limits of the observable universe, an astronomical marvel stretching about 93 billion light-years in diameter. This begs a fascinating question. If the universe is only 13.8 billion years old, how can it be so vast? The answer lies in the nature of cosmic expansion. The universe has been expanding since the Big Bang, stretching space and increasing distances between celestial bodies. Some regions of space are expanding away from us faster than the speed of light, placing them forever out of our view. Consequently, the true size of the entire universe remains unknown and potentially infinite. The observable universe, vast as it is, might just be a tiny fragment of the entire cosmic expanse. We are left with the humbling realization that there might always be regions of space, entire galaxies, and wonders that we will never witness as they retreat endlessly into the depths of the ever-expanding universe. Yet, amidst this vastness, we find meaning in our quest for understanding, in our desire to explore, and in our appreciation of the delicate blue dot we call home.